shifting to turn this primary into.
There's no hydrogen in the middle.
Yeah, right? And there's no hydrogen, so what can we shift?
We're done.
Oh, metal.
What?
Oh,
Oh.
shifting the entire.
So this is a methyl shift.
Okay.
And that. And then it becomes tertiary.
Wait, what the? How'd you do that?
There's no available hydrogen, so you need to move the metal to kind of.
So you just
distribute
break
the gas.
apart the methyl and place it
Yeah.
two carbons away?
It's a metal.
Oh, check it.
So that's going to be the two types of rearrangements. You'll see a hydrogen shift or a methyl shift. And this is an example of methyl. So if this was like this, then we could have moved like the hydrogen that would be attached. But since it has 4 different groups that this carbon's attached to, we can't move a hydrogen, right? Yeah. So we're going to move the methyl instead.
Could we move either?
I would say if there's
Just make-
a hydrogen, you're most likely going to be shifting the hydrogen.
No, I meant as in like either methyl. Would it make no
Oh,
difference?
either methyl, yeah.
Okay.
It doesn't matter. Because they're both the same group.
How does the question look like on the exam? Like, do they just give you this? Sorry, I didn't look at
You would be given like,
Just the top part.
yeah, just the top.
Yeah.
Like the H2SO for heat,
Yeah.
BR2.
Yep.
Yeah.
Right here, the exam's right here.
Oh.
And then tertiary. Okay.
Oh.
Yes.
Oh, E1's always going to be Hoffman or Seitzman.
But if you see heat, anything with the temperature, you know automatically it's going to be SN1.
Oh,
If
it's
you want,
not.
if it's heat, it's equal because it's
Yeah.
increased temperature. If there's no heat, then it's like.
Yeah, if there's no heat, it's SN1, but I haven't seen him ever do that. It's always been H2SO4 with heat.
So it's
E1. Yeah.
I hate this class. So hard.
And E1 is always Seitzman, right?
Oh, yes.
So the alkene can add here, here, or here. If it adds here, it's primary or secondary. If it adds here, it's tertiary and here tertiary. So you can either add here or here, it doesn't matter.
Oh, he did solve a problem very similar to this in class.
Yeah.
He's like, oh yeah. How do we know which one to go to with either to more or less?
So E1's always going to be Seitzman.
What does that mean?
More.
Zigzag?
substituted.
No,
More
more.
substituted.
Alpha
I thought-
is attached to more.
I thought the only more is the bulky or thin or small.
No.
What's zigzag?
For bulky base, it's always going to be Hoffman actually. So less.
What? Okay. Well, now we're getting to names. I thought. What does zigzag mean?
That's
Zaitsev.
That's a person, name of a person.
Sure. What does it mean? What does he represent?
Zaitsev, more substituted alkene.
Okay.
So you pick your arrangement that has more substituents.
Exactly.
Okay. Sure.
So if
What
it's-
about the bulky? I'm so sorry. What about the bulky or
So if you had a bulky base,
bulky base?
so this, it's
Yeah.
always going to be E2 Hoffman. So Hoffman's going to be the less substituted.
So bulky, so big ones are, and then Hoffman, which is less substitute. Small bases are zigzag.
Small base,
Zigzag.
Yeah, small bases are size.
Zaitsev. If it's E2.
Yeah. Of course.
Because Zaitsev Hoffman is just for
If it's equal.
elimination reaction.
And then
No,
E1 is
sorry.
always.
If it was H, would you add the bond on the bottom?
And H.
The cuffs minus plus.
Oh, like here? Like instead of the methyl and H?
Instead of the Z.
Oh, instead of, H, Hoffman. If it was Hoffman, I would add it here.
Okay.
Yeah, because then there's only two.
But E1 will never.
Yeah, I just wanted.
Yeah, you wouldn't
There's
have
no way to get
to worry about
everything is the same.
E1, you wouldn't have to worry about the side stuff.
I have a question though. Instead of a methyl transfer, what if you took the hydrogen that's attached to this methyl, placed
No.
it here and put the plus sign here and an alkene there?
It always has to be on adjacent carbons. to this.
So it has to be only that carbon that's working on it.
So this is the only adjacent carbon, right?
Yeah,
And
now
then
it's
only
two
then
carbon
it
to
goes
it.
to the methyl group.
Yeah, so this carbon has two methyls, yeah. And then for Br2Cl or CCl4.
Oh, we're not done with this problem.
No, yeah, it's just,
This has the table she's looking at.
it's
It's
starting to,
adding the two halogens across the double bond anti. So Br.
it's starting to make sense. I'm sure when he reviews the different questions, if we, yeah, I'm gonna use this weekend and just understand
Why is
it.
it anti-sheet?
It's listed in the table.
Yeah,
Oh, right.
literally just, yeah. I'm assuming whatever problem he gave us, at least one part of it is going to be on the table, right?
Oh,
Okay.
So the second part is not that hard.
Yeah, no.
Look at the table.
Chapter 8's part is really fine. It is all in the table.
The first part is really good.
Chapter 7, like the summarizing because you have your own tables.
Yes,
Yeah,
I would
yeah.
memorize the tables.
You're gonna include those tables in the what? Perfect. Thank you.
Yeah.
Because that's a fun
Oh, we gonna get 100 now.
I wish.
That's my first second.
Usually my second chem exam goes well.
What?
Yeah, it's usually the more difficult
Wait,
ones.
did you already add the halogens?
My first
Yes,
exam is all
I
shit.
did.
Oh.
Oh, wait, for the second part?
Yeah.
Oh yeah, can you wait? I missed that.
I'll retry it. So it was halogens anti-addition, right? The alkenes here. So on either end, it's gonna be one wedge Br and a dash Br. Because it's anti, right? If it was syn addition, they would both be on wedges or both dashed.
Well, what about the CCl4?
That doesn't matter. It's just like one of the reagents for the reaction.
Oh.
You're adding the Br2.
Oh.
You get rid of the
I don't even know what that
I
means.
just added a BR, because there's two BRs, you add one BR on one seat and one BR.
Wait, does it tell you which one's the reagent and which one's the?
Yeah, so in the table it's listed as halogenation. And then it says X2, right? X can be Br, Cl,
Oh, in CCl4. Okay.
Yeah,
On the
and
exam.
then it can tell you to add the two halogens.
CCl4 is just a solvent. Right?
Yeah.
Like this one says 0.3 GMS. It's on 0.3 GMS. Dinner is aldehyde such ketones. So this, you add, an aldehyde or ketone in your, if you can see one of this again. The BR2 CCl. What exam year was that one?
That one was.
The BR2.
One second. That was spring 2022. Problem 6A.
Oh, we don't have 2022.
You don't? I mean, it's on the slides. I put it. Okay, this we said was a small base, yeah. Small base. This BR is secondary. Why? Because the carbon it's attached to is attached to this carbon and this carbon.
In class, he always references it from like the carbon. He never references it from like the halogen.
Okay.
He looks at where the carbon is and says what is that carbon? Is it primary, secondary, tertiary?
Yeah, but like to know like which carbon to look at is the one attached to the halogen, right? And then that one's attached to. This secondary small base is what is it? E2?
E2.
Yeah. E2. Sorry. where would the alkene add? Here or here? For Zysa?
There, in the middle.
In middle, yeah.
Wait, no,
No.
It's more substitute.
no, because then we'll have 5 ends.
Yeah, yay, okay. So the reason this problem was tricky was because carbon can't have
Yeah, it's not gonna be optimal.
Wait, what's going on?
more bonds.
You cannot add like a bond there because then the carbon in the middle will have 5
Yeah.
ends.
So you cannot go to the left, so you have to go to
Yeah,
the
so
right.
even though Zaitsev would want it to go here, carbon can't have more than
So
4
it'll
bonds.
just be there.
So it'll be Hoffman.
So this stereo, this is not stereo.
This is not stereo, but this was one of like the trick.
There's only one option though, so why would I do stereo?
Stereo specific.
Not to, like, why is it not because if it's only one option, it's not.
Girl, you're what?
It's not half forcing or something. I mean, it's half.
Yeah,
You got this.
yeah, I just said that because we would normally do Zaitsev, but in this case we can't. Because if it were to add to the more substituted side, the carbon would not obey the octet rule.
How would you know it's possible?
Next week, Friday.
Oh,
Only to the primary?
it has to add to one of the sides, right? So if it can't add to Zaitsev, it's gonna add to where it would for Hoffman. Same thing for stereospecificity. If the Zaitsev side has a hydrogen that is not the opposite of the halogen, then you're gonna add it to the less substituted side that has a dashed hydrogen, for example.
Oh, is there something for the hydrogen? I'm not confusing all of them.
Yeah, stereospecificity was like this, like BR is on a wedge, and then like you're given this, right? And then the hydrogen, or sorry,
Actually, yeah, no, it's gonna be other way.
And that's its own.
the hydrogen would be on a wedge, right? Because the methyl's on a dash, and then this one has
It's only the same.
So in that case, you cannot have a double bond within the H and the BR because
Yeah.
they're both single line. Sorry,
yeah. So you, if this were to be like a Zaitsev reaction, you can't add it here because they're both on resonance. It has to be opposite.
So we would have
Hijo de su madre.
Or because of the small base it's sensitive.
Yes.
But if they have no choice, it's stereo
HBr was marked.
¿Quieres? Tengo una idea.
Rearrangement possible. Yeah, addition of BR, so it's gonna add BR, mark, and rearrangement is possible.
Where would you add this?
So mark indicates more substituted side of the alkene, right?
Oh, teacher. Sorry.
But since rearrangement is possible, we are going to see if that's
Wait, what does mark mean?
on the, it's gonna add to the more substituted side of the alkene.
Okay.
So it would add like here. But since rearrangement is possible, I'm first gonna do this.
There's a rearrangement possible. Oh, a hydrogen.
So let's say, so if the alkene leaves, right, the carbocation is gonna be here. Never form a primary carbocation. And then here, what can we shift?
Methyl?
Yeah. So this methyl.
Do you add the hydrogen and BR first, or do you do it after rearrangement?
After rearrangement. So if the table says rearrangement possible, always check for it first and then do that first.
And how do you want to rearrange it?
So the alkene would leave. Carbocation is gonna go never on the primary side, on the other end.
How do we know the alkene is leaving?
What was that?
We just know. How do we know the alkene?
Oh, just, yeah, if you get to this point and then have this, and you're rearranging, remove the alkene, the carbocation is gonna go here, and then since it's secondary, And if it moves here, it'll be tertiary. We're gonna shift the methyl. So it'll be here. And then the BR is gonna attack the carbocation. And you're left with this.
I don't understand the arrangement.
Yeah. So if you have an alkene and then you're rearranging, you're going to get rid of the alkene, like protonate it with the hydrogen, and then the carbocation is going to be not on the primary side, but like the secondary side, because primary is going to be really unstable. And then we want to make it tertiary, so we're going to shift the methyl in this case.
Oh,
Sorry.
do you add a hydrogen to the other carbon? Like the carbon in that side, like the end? Like, what do you mean by protonated? You add a hydrogen to that carbon? Like this carbon, I mean. Do you add it here?
Oh yeah, yeah.
Yeah, so like you take this out, you add a hydrogen here, and then this one becomes plus because it doesn't have.
Exactly.
Okay.
Yeah, but you don't have to write hydrogen.
Yeah.
And then you do the metal shift.
Yeah, methyl shift, carbocation becomes tertiary. Br, so Br minus is gonna attack there, and then we attach there.
Oh, okay.
Yeah.
Because light charge neutron.
And then again, this is the same thing, right? Small base.
Oh, there's a third step.
This
Yeah,
time
it's
it's tertiary.
Equations.
Tertiary small base was E2. Yeah.
No? Isn't it just a thick board?
That's,
You said this is only part of chapter 8? Well, it's only part of chapter 8, the market and cipher.
yeah, this part is chapter 8. These two are chapter 7.
Okay.
Yeah.
Can we skip the alkene part? Like, can we look at it and see that when bromine is removed, there's gonna be a cation there, so we have to check the rearrangement before we add an alkene? Because we kind of add the alkene and then we just go back and remove it.
You mean like not doing this?
Yeah.
On the exam, you have to write the products for each of these.
Oh.
Yeah,
Oh,
not
that's-
just the final.
Oh.
Yeah,
And that's the product for.
yeah. So this is the product of this.
Mm.
This is the product of this, and this is that.
Can you put like 1, 2, 3, whatever?
Yeah, this is like the rearrangement part. This you don't have to write, but it's helpful for the if you can like do it in your head, then yeah, you don't have to write it. But E2 Zaitsev, so would the alkene add here, here, or here?
Yeah, orgo's kind of fun.
Oh, we don't. All the hydrogens are. Is there any dashed hydrogens or how do we know that?
Oh, you don't have to worry about that here.
Okay.
You only worry about stereospecificity if you start off with like a BR on a wedge.
Oh, okay. So, alright, then we don't have to worry about that.
It's gonna be.
It's gonna be in the middle.
Which side is it gonna? Here, yeah.
Yeah.
Yeah, because it's the most substrates. Yeah. And the BR leaves, right?
Yeah.
Wait, what's happening on the last one? It's just small base and.
Oh yeah, small base, tertiary, substrate. So E2 Zaitsev.
But wait, the BR doesn't have more than 4 bonds.
The BR doesn't have 4 bonds.
Yeah, it's connected to one
It only has
organ.
1 bond.
Yeah.
No, I mean for the other one. It's usually that it's 1, 2, and then we have 3, and then we have a double one. Where on the last
This one?
Yeah.
No, there's no BR anymore.
I mean the carbon.
The carbon?
Yeah.
Which one? This one?
1, 2, 3.
Yeah.
1, 2, 3, 4. 1, 2, 3, 4. No, this is fine, yeah.
Oh yeah. Oh, never mind. I'm kind of.
Yeah. That was there. Where we were saying that
We wanted one in the
it
middle.
couldn't add here because then it would be 1, 2, 3, 4, 5. Yeah.
I didn't
Could you do one with tertiary solvent? Because I'm confused how you can have both SN1 and E1.
Tertiary, what did you say?
Solvent, because you put E1 slash SN1 slash E1.
Oh, okay, for that, if it's, if you see this, these have an
Excuse me,
open
sorry.
alcohol and H2SO4 with heat. This will be the only instance where you do E1. Okay, alcohol with H2SO4, which is a strong acid, and heat.
Okay.
Yeah.
So for this last step,
Yeah.
where you made it into an alkene, your options were to take hydrogen from the left or the right.
Yeah, the options are hydrogen from here, or hydrogen from here. Right? So you can either go here, here, or here.
Oh, okay.
And since it's side step, we look for the one that's going to result in a more substituted one, and it'll be there. Yeah. Let's say it was Hoffman, you could put it here or here, right? Yeah.
Okay.